Hello and welcome to a comparison of the intersecting versus the parallel models of externalities. Now, here's the intersecting model, such as we see in our Parkin and Baudet model, and here's the parallel model, such as we often see emphasized in other textbooks and by the College Board, the makers of the AP exam. Now, the model that we see in our textbook, the intersecting model, looks like this. And it's actually a superior model for a couple of reasons. One, it shows the reality that down here at a very low level of production, the cost of the externalities is either zero if no units are produced, or very little if very few units are produced, and they increase. The negative externality in this case increases drastically as more and more units are produced, and that coincides with reality. If no units of paint are produced, then no toxins will be produced. And if millions of units of paint are produced, then millions of toxins will be produced. So it's a little more realistic, and so that's a good thing. The other thing is this model will help us see how we arrive at equilibrium, whereas the parallel model simply shows us where we arrive, but it does not show us how we get there. Let me explain. Using the intersecting model, we can see that the cost of the externality at our private equilibrium, the equilibrium we'd have if no intervention was pursued by the government, we see that the cost of the externality is this much, the space between our private costs and our total social costs. So if we applied a tax, it would be in this amount. Now that would not get us over here in one single tax. We'd actually have to bump around a number of times, shooting below our socially optimal output, and then back above, and then below again, before we finally landed on our socially optimal output. But our intersecting model here shows us how that would work. See, if we applied this tax, that would bump our private marginal costs way up to here. Now this curve will intersect with our marginal social benefit curve way over here. And as you can see, we will greatly overshoot our socially optimal output. Okay, so fair enough. We end up here now. Now, over here, we're greatly underproducing what this market actually wants in terms of this product. Although there's a negative externality, we still do want this socially optimal quantity, and we're not producing nearly enough. However, at this very low output, the value of the externality is also very low. So, fair enough. We would reassess our Pigovian tax and apply this amount of tax. Now, at that amount of tax, our marginal cost comes way down. Now, our new marginal cost curve intersects with our marginal social benefit curve over here. Again, we have overshot our socially optimal output, but not by that much. So fair enough. Now we're over here. Again, we reassess the tax. We find at this level of output the tax is this much. We apply that tax, and we bump our marginal cost curve up again. As you can see, we've overshot once again, but this time by very little. We will reassess the tax, and eventually, in probably 2 or 3 more taxes, we'll end up here at our socially optimal level of output. Fair enough. So this is where we end up. Now, this may seem a little familiar. If we take a look at where we end up here in the intersecting model, it looks very much like this, the parallel model. The parallel model shows us where we end up. However, it does not and it cannot show us how we get there. So, I would assert the intersecting model is the superior model to use.